Every white shark at the colony is gone. Not scattered. Gone. The water stays empty for weeks. Then a body washes ashore, a great white, intact, except for a single clean opening behind the pectoral fin. The liver is missing. Nothing else was taken. This is the animal that gave the ocean its reputation. And it did not fight. It left. Sharks do not flee everything bigger. They flee this, and they stay gone. Whatever opened that shark knew exactly where the organ was. To understand why the shark loses, you first have to understand how good it actually is. Because the great white is not a weak animal. It is one of the most expensive predators the ocean has ever built, and almost nothing about it is standard equipment. Start with the temperature. Pick up a fish out of cold water, and it will feel cold, because a fish is cold. Its blood runs through its gills, presses up against thousands of thin membranes to grab oxygen, and in that same moment, it dumps every scrap of body heat straight into the sea. That is the deal every fish makes. You breathe water, you lose your heat to water. There is no way around it, which is why the ocean is full of animals that run at exactly the temperature of the water they are floating in. The white shark broke that deal. Inside its body, tucked in tight against the spine, rather than sitting in a thin sheet under the skin where most fish keep it, there is a band of dark red swimming muscle. That placement alone is strange. Most fish put their power muscle on the outside, close to the water, close to the cooling. The white shark buried it, and wrapped around that muscle is a structure that looks, in cross-section, like something out of a heat exchanger in a factory. Hundreds of tiny arteries and veins pressed together, running in opposite directions, so that warm blood leaving the muscle passes right alongside cold blood coming in. The heat jumps sideways from one vessel to the other before it can ever reach the gills. It never escapes. It gets recycled. The result is a shark with a warm core inside cold water, not slightly warm. Measurements of stomach temperature in white sharks have come back elevated above the surrounding water by more than 14 degrees Celsius. Imagine holding your hand in water cold enough to hurt and finding a pocket inside it that feels like a warm bath. That is what a white shark is carrying around under its skin. And this is where it stops being a trivia fact and starts being a weapon. Warm muscle contracts faster. Warm muscle recovers faster after a burst. Warm nerves transmit faster. The white shark does not just keep its swimming muscle warm, it keeps its gut warm, which means it digests a heavy meal in cold water instead of sitting on it for days. It keeps blood flowing to the region, around the eyes and brain, which means its vision and its reaction time do not crash when the water temperature does. A cold-blooded fish in 10-degree water is a slower fish. A white shark in 10-degree water is still, functionally, a warm animal, running a warm animal's reflexes. That single trick unlocks a map. Most large predatory fish are locked into warm water because their whole body chemistry slows to a crawl outside it. The white shark can leave. It can push into the cold, gray, productive water where the food actually is. The water off California, off South Africa, off South Australia, off the Northeast United States, and hunt there at full performance, while everything around it is running at half speed. It can move between temperature zones that would shut other fish down. It gets access to a world of prey that nothing else its size can reach. Then, look at what it hunts there, and the whole design snaps into focus. Seals, sea lions, fur seals, animals wrapped in a thick layer of blubber, which is the densest, most calorie-loaded food available anywhere in the upper ocean. A shark that stays warm needs an enormous amount of fuel, far more than a cold fish of the same size, because heat is not free. Every degree above ambient is being paid for by burning food. So the warm body demands fat, and the fat is sitting on a seal, and the seal lives in cold water, and only a warm-bodied shark can chase it there at speed. That is not a coincidence. That is a system. The teeth follow the same logic. A white shark's upper teeth are broad triangles with coarse serrations along the edges, and they are not built for holding. They are built for shearing. Put that edge into blubber, and it works like a saw pulled through soft fat, taking out a bite that can remove a section of an animal in a single pass. The lower teeth are narrower, more pointed, better at gripping and pinning, while the uppers do the cutting. Two different tools in one mouth, working as a pair. And behind them, more rows waiting, sliding forward on a conveyor of soft tissue, because a shark that hits bone and loses teeth cannot afford to be disarmed. It replaces them for its whole life. Under the skin, there is no bone at all. The skeleton is cartilage, lighter than bone, more flexible, stiffened with mineral in the places that need to take load. That saves weight, which matters enormously for an animal with no air-filled swim bladder. And the skin itself is not smooth. Run your hand along a shark from nose to tail and it feels like leather. Run it the other way, and it feels like sandpaper, because the surface is covered in millions of tiny tooth-shaped scales, each one grooved, each one angled backwards, breaking up the water flowing over the body so it clings less and drags less. And the senses are worse than you think. Worse in the sense of more. Smell first, over long distance. Tracking a scent plume in a moving three-dimensional fluid. Then the lateral line, a channel of fluid-filled sensors running down each flank, reading pressure changes in the water, picking up the specific irregular thrash of something injured or panicking from a distance where there is nothing to see. Then vision, in the final approach, adjusted for low light. And then, at the last moment, the strangest one. Across the snout, above the eyes, under the chin, clustered in patches you can actually see as dark pores in the skin, a white shark carries hundreds of jelly-filled tubes, called ampullae of Lorenzini. Each one is a detector for electric fields. Every living animal leaks a faint electrical signal simply by having a beating heart and contracting muscles and a body chemistry that differs from seawater. Experimental work on sharks has shown responses to fields on the order of a few billionths of a volt per centimeter, which is a level of sensitivity that has no equivalent in human experience. There is no comparison to reach for. We do not have a sense that operates in that range. Here is why that matters. And this is the part that gets left out. In the instant a white shark bites, it cannot see. As the jaws come forward, the eye rolls back in the socket to protect it, because prey that fights back can blind a predator, and a blind predator starves. So the shark goes into the most dangerous half-second of its life with its vision switched off. The electrical sense is what fills the gap. It is tracking the target by the electrical noise of the target's own body in the dark, at contact range, with its eyes rolled away. That is not an animal that got lucky. That is an animal that has been solved. So look at the whole package. A warm-bodied fish with buried heat exchangers, an expanded thermal range, blade-edged replaceable teeth, a weight-saving cartilage frame, drag-reducing skin, and a stacked sensory system that hands off from smell to pressure to sight to electricity as the distance closes. That is what is swimming toward the seal colony. And this is exactly the problem, because an animal built like that should not abandon anything. It should not run. It should have no reason to. When something that well-equipped disappears from its own hunting ground and does not come back for a season, the interesting question is not what scared it. The interesting question is, what could possibly be worth being that scared of? Before that can be answered, there is a piece of the shark's design that has to be understood first, and it is the piece almost everyone gets wrong. Because the image in your head, the shark cruising the coastline all day looking for something to eat, is not how this animal works at all. The white shark is not a hunter that hunts constantly. It is a hunter that waits, then spends everything at once. At Seal Island in False Bay, off South Africa, researchers spent years sitting on the water watching Cape fur seals leave the rock in the morning and come back later, and watching white sharks work them. What came out of that work is one of the clearest pictures we have of how this animal actually makes a living, and it is far more restrictive than the reputation suggests. The attacks are concentrated in a narrow window. Predatory success at Seal Island. COIH was found to be highest in the first hour after sunrise, at around 55%, and it fell off fast as the light came up. That is not a small effect. That is the difference between a hunting strategy that works and one that does not. And when the success rate dropped to roughly 40%, the sharks stopped actively hunting. They did not push on and try harder. They shut it down. Think about what that implies. The shark is running something close to a cost calculation. Every failed strike burns energy in a body that is already expensive to keep warm, and every strike carries a risk of injury from a seal that can twist, bite, and claw. Below a certain hit rate, the hunt stops paying for itself, so the animal stops. The window closes. Why the first hour of light? Because the entire attack depends on one thing the shark cannot manufacture, not being seen. The white shark's body is painted in two tones, dark gray on top, dirty white underneath, with a hard line where they meet along the flank. From above, looking down, the dark back vanishes into the dark water below. From below, looking up, the pale belly vanishes into the glare of the surface. It is a camouflage scheme, designed for an animal that lives in the middle of a water column and needs to be invisible from both directions at once. Now put that body deep, under a seal that is swimming at the surface. The seal is silhouetted against the sky. It is a black shape on a bright ceiling, visible from 30 meters down. The shark is below it in the dark, looking up, holding position, watching. The seal, looking down into blue-black water, is looking into nothing. It has no silhouette to work with. The physics of light in water hands the entire advantage to whichever animal is deeper. That is the whole hunt, and it is over in seconds. The shark commits vertically, straight up, accelerating into water that gets brighter as it rises, and hits the seal from directly underneath. At Seal Island, the initial strike was most often what researchers described as a polar breach, the shark coming almost vertically, and carrying its own momentum plus the seal clear out of the water. Several hundred kilograms of shark leaves the ocean entirely. Most of these attacks lasted less than a minute. Many were a single breach, one attempt, and then it was over one way or the other, which means the success rate is decided before the shark ever moves. The Seal Island work found the sharks were not attacking randomly. They favored lone seals rather than groups, young of the year rather than adults, seals coming in rather than going out, and specific depths and locations around the island. This is a predator that is picking the weakest possible geometry and refusing everything else, not because it is cowardly, because it has to. A young seal alone at the surface at dawn is the only version of this fight the shark reliably wins, and when it misses, it does not chase. The detail most people find hardest to accept is this one, because it does not match the image. The strike fails, the seal breaks away, and the shark usually lets it go rather than turning it into a pursuit. There is another layer to this. Studies at Seal Island found predatory success dropped sharply with each additional breach, so a hunt that turns into a series of attempts is a hunt that is already failing. And success was actually lower in the areas where sharks hunted most, which points to the sharks rushing suboptimal strikes when other sharks were competing for the same water. So the picture is not an unstoppable killing machine. The picture is a specialist with one very good move that only works under a narrow set of conditions, that expends a huge amount of energy in a few seconds, and that stops the moment the numbers turn against it. There is a second reason for the withdrawal, and it has nothing to do with arithmetic. It has to do with damage. A white shark has no hands. It has one tool, and that tool is its face. Every weapon it owns is mounted on the same structure that carries its eyes, its nostrils, its brain, and every one of those electrical sensors. When it bites, it is putting its most fragile and most irreplaceable equipment directly into contact with an animal that is fighting for its life. A Cape fur seal has claws and teeth and a spine that can fold in half. It can turn inside the shark's turning circle, and it is aiming for exactly the same thing the shark is protecting. This is why the eye rolls back. This is why the strike is one enormous committed hit and then separation. The shark is not being patient. The shark is getting away from the part of the encounter where it can be hurt. Wait. Let the wound do the work. Come back when the fight has gone out of the target. That is a strategy built entirely around the fact that the predator itself is breakable. And that is the crack in the whole design. Every part of the white shark's hunting system assumes the same thing about the target. It assumes surprise is possible. It assumes the target does not know it is there. It assumes the fight will be short, one-directional, and against a single animal that will try to escape rather than counterattack. Take away any one of those assumptions, and the shark has nothing to fall back on. There is no second move. There is no plan for an opponent that sees the approach coming, does not panic, does not scatter, and does not run. There is certainly no plan for an opponent that arrives with 4 other opponents and a system for what each of them does, which brings the story to the thing that killed the shark on the beach. The easy explanation is size, and it is the first thing everybody reaches for. An orca is bigger. Large males can exceed 8 meters and weigh several tons, well beyond even an exceptional white shark. So the story writes itself. Big animal beats smaller animal. End of discussion. That explanation falls apart almost immediately, and it falls apart on a piece of evidence that is genuinely difficult to explain away. On the 18th of June 2023, at a different seal island entirely, this one off Mossel Bay, several hundred kilometers east along the same South African coast, observers on 2 boats about 800 meters offshore watched a single killer whale attack a juvenile white shark, roughly 2.5 meters long. It gripped the shark by the left pectoral fin, drove forward with it repeatedly, and eviscerated it. The whole event was over in under 2 minutes. It then fed on the liver at the surface, in view of the people on the boats. That was the first time anyone had documented a solitary killer whale killing a white shark, and it was published in the African Journal of Marine Science in early 2024. What makes it so useful is the contrast with everything that came before it. Previously documented attacks on white sharks in that region involved somewhere between 2 and 6 killer whales and could take up to 2 hours. So the same species on the same coastline, killing the same prey, went from a 2-hour group operation to a 2-minute solo job. Size did not change. The animal did not get bigger between one event and the next. What changed was the method, and that is the actual gap between these 2 predators. It was never mass. It was never bite force. It was the fact that one of them is running a technique, and a technique can be refined, shortened, optimized, and handed to somebody else. A body cannot. Look at how orcas hunt everywhere else, and the pattern is unmistakable because it is not one pattern. It is dozens, and they do not overlap. In parts of the Antarctic, killer whales hunt seals resting on floating ice. The seal is out of the water, which should make it unreachable. The whales solve this by lining up shoulder to shoulder, swimming hard at the flow together, and diving in unison at the last instant. The mass of water they push ahead of them rolls over the ice as a wave and washes the seal off. This requires the animals to be in the right positions, moving at the right speed, at the same moment, aimed at a target none of them can grab on their own. It is not something one whale can do. Off the coast of Patagonia in Argentina, a different population hunts sea lion pups in the surf by deliberately driving themselves up onto a sloping beach, grabbing the pup, and then working their way back into the water on the retreating wave. Beaching is, for a marine mammal, close to the most dangerous thing it is possible to do voluntarily. Get it wrong, and you are a several-ton animal stuck on gravel with your own weight crushing your lungs. Young whales in that population have been observed practicing the movement repeatedly, in conditions where there is no prey to catch. Researchers have long argued that a maneuver with that much risk and that much precision is not something an animal invents alone in the moment. In the fjords of Norway and around Iceland, killer whales work herring. Herring in open water are a nightmare target because a school moves as a single evasive object, and no individual whale can corner it. So the whales corral it. They circle the school, drive it upward and inward against the surface where it has nowhere left to go, and release bursts of bubbles that the fish will not swim through, building a wall out of nothing but air. Then they hit the compressed ball with their tails, stunning fish by the dozen, and pick them off. Different whales take different roles in this. It goes on for a long time. It is closer to industrial harvesting than to a chase. None of those three techniques is available to the others. An Antarctic wave washer does not know how to beach. A Norwegian herring specialist does not wave wash. These are not different species. They are the same species doing completely different jobs, and the difference between them is not in their bodies. It is in what they know and where that knowledge is kept. Killer whale society is built around the mother. Groups form as matrilines, a female with her offspring, and those offspring with theirs. And in some populations, the sons and daughters never permanently leave. They stay with her for life. That is not a family in the loose way the word gets used for animals. It is a stable. Is a stable, multi-generational unit in which the same individuals swim beside each other for decades, hunting the same prey in the same waters, watching each other do it thousands of times. Put a hunting technique inside a structure like that, and something happens that cannot happen inside a shark. The technique stops dying with the animal that invented it. That is the entire difference, and it is worth sitting with for a second, because it sounds smaller than it is. A white shark that stumbles onto a better way of taking seals has discovered something that will vanish completely when it does. There is no one to hand it to. Young white sharks are not raised. They are born, fully formed, and roughly 1.5 meters long, and from that moment, they are alone. They never meet their mother again in any way that means anything. Whatever they learn by themselves, from their own mistakes, and then it is deleted. A killer whale calf spends its first years attached to an animal that already knows how to do the job. And once information can move between generations, it starts behaving less like biology and more like technology. It accumulates. It gets modified. It spreads sideways through a group and downward through time. And the animals carrying it are not limited by how fast their bodies can evolve. A body has to wait for mutation, selection, and generations of death to change anything. A technique can change in an afternoon. So when people say orcas are intelligent, that word is doing too much work and not enough. Intelligence is hard to measure across species, and any confident number should be treated with suspicion. What is actually documented and far more interesting is that killer whale populations carry different bodies of knowledge that are not written into their genes, and that those bodies of knowledge are strong enough to split the species apart from the inside. This is where it gets genuinely strange. In the coastal waters of the northeastern Pacific, there are killer whales that eat fish, particularly salmon. There are also killer whales that eat marine mammals, seals, sea lions, porpoises, the calves of larger whales. Both are Orcanus orca. Both live in the same water. They pass through the same channels, sometimes on the same day. They do not mix. They do not hunt together. They do not, as far as the genetic evidence shows, interbreed. They have different sounds, different social structures, different behavior on the surface, different diets, and they have been genetically diverging from one another for a long time. Nothing physical is keeping them apart. There is no mountain range in the sea, no barrier, no temperature line they cannot cross. The separation is behavioral. It is what they eat and how they were taught to get it. Two groups of the same species, sharing an ocean, split into separate worlds by culture alone, and that split is now showing up in their genomes. Researchers have described this as genome and culture evolving together, with the learned behavior arriving first and the biology following it. That is not a fact about whales. That is a fact about what happens when information gets loose in a population. The fish eaters and the mammal eaters even hunt in incompatible ways for reasons that trace directly back to their prey. Salmon cannot hear a killer whale coming in any useful way, so the fish-eating groups are noisy, calling constantly, coordinating out loud. Seals and porpoises hear extremely well, and a chatty predator is a predator that goes hungry, so the mammal hunting groups go quiet. They hunt in near silence, using far less sound, moving in small groups. Same species, opposite acoustic strategy, both correct. For the animal, each one is trying to eat. Now bring that back to a great white shark. The shark has no equivalent of any of this. It has an outstanding body and no way to share what that body has learned. It cannot be told anything. It cannot be warned. It cannot be shown. It cannot inherit a countermeasure from an animal that survived one. Every white shark that meets a killer whale for the first time meets it as a complete stranger, with no preparation, running the same hunting software it was born with. And on the other side of that encounter is an animal whose method is still being written, which raises a question that only has bad answers for the shark. What happens if a killer whale population starts refining a technique aimed specifically at white sharks? Because that appears to be exactly what has been happening. Begin with what washes up, since that is where the story became impossible to ignore. Along the coast of the Western Cape in South Africa, starting in 2017, white sharks began coming ashore dead in a very particular condition. Not chewed, not scavenged into pieces. The bodies were largely intact, which is itself the strange part, and there was usually a wound in the region between and behind the pectoral fins, an opening into the body cavity. Through that opening, the liver had been removed. In many cases, that was all that was gone. Sometimes the heart or the reproductive organs were also missing. The rest of the animal, several hundred kilograms of meat, was left. 2 adult male killer whales were repeatedly present in the area around these events, distinguishable at a distance, because both have collapsed dorsal fins, one leaning left and one leaning right, which is how they got the names port and starboard from a local operator who saw them off Cape Town. At first glance, this reads as gruesome trivia. It is not. It is a precision problem, and the precision is what makes it hard to dismiss. To understand why, you need to know what a shark's liver actually is, because it is not the organ you are picturing. In a bony fish, buoyancy is handled by a swim bladder, a gas-filled sac that gets inflated or deflated to hold the animal at a chosen depth. Sharks do not have one. They never evolved one. A shark is made of muscle, cartilage, and water, and all of that is denser than seawater, which means a shark, left alone, sinks. The solution is oil. The shark's liver is enormous. Across sharks generally, it can run somewhere between roughly 1/10 and 1/3 of the animal's entire body mass, and in some deepwater species, it reaches the upper end of that range. It is the largest organ in the body by a wide margin, and it is loaded with low-density oil, much of it a compound called squalene. Squalene has a density of about 0.86 grams per milliliter. Seawater is about 1.026. That difference does not sound like much until you multiply it across tens or hundreds of kilograms of tissue, at which point it becomes a flotation device built out of fat. So the liver is the shark's swim bladder. It is the reason the animal can hold depth without swimming upward all day. Take it out, and the shark, physically, cannot stay off the bottom. That would be enough on its own. It is not the whole story. Oil is also the densest form of energy in biology. Gram for gram, fat carries roughly twice the usable energy of protein. So the same organ that keeps the shark suspended in the water column is simultaneously its fuel tank, its long-term energy store, the thing it lives off between kills, the reserve it draws on during long migrations across open ocean where there is nothing to eat. A white shark's liver can be a substantial fraction of its total weight, and almost all of that is high-grade oil, which means when a killer whale opens a white shark and removes only the liver, it is not taking a random organ. It is taking the single most calorie-dense object inside that animal, and it is leaving behind hundreds of kilograms of muscle that would cost time and energy to process for a fraction of the return. From the position of a predator that has to fuel a large, warm-blooded, constantly moving body, that is not squeamishness. That is the highest possible payoff for the smallest possible amount of work, taken from an animal that is dangerous to be near. Now, the precision matters. Getting the liver out of a live white shark is not a matter of biting it and hoping. The organ sits inside the body cavity, behind the gill region, and the way to reach it is to open the shark along the underside in the area between the pectoral fins. Descriptions of the South African carcasses repeatedly point to wounds in that region, and to the body being opened rather than dismembered. The pattern is consistent enough that it has been used as a signature, and that signature has now been confirmed somewhere else entirely, by a method that does not rely on anybody's interpretation of a wound. In October 2023, a white shark measuring 4.7 meters washed ashore in southeastern Australia, near Portland in Victoria, at the same time that people in the area were reporting killer whales hunting something large. The carcass was missing its liver along with the digestive and reproductive organs, and carried 4 distinct bite wounds. One of those was the characteristic opening seen in South Africa. Instead of arguing about the wounds, researchers swabbed them and sequenced what they found. The major bite carried killer whale DNA. Other bites on the carcass carried the DNA of broad-nosed seven-gill sharks, which is exactly what you would expect from scavengers arriving after the fact rather than from the animal that made the kill. That result, published in Ecology and Evolution in early 2025, did 2 things at once. It confirmed killer whale predation on white sharks in Australian waters with genetic evidence rather than inference, and it made the liver removal pattern a great deal harder to treat as a local curiosity belonging to 2 unusual animals off South Africa. The same behavior in oceans that do not connect in any simple way, aimed at the same organ, accessed the same way. Here is where the honesty has to come in, because this is the point where a lot of retellings quietly slide from evidence into storytelling. We do not know why killer whales target the liver. We can see that they do. We can measure what is missing. We can point at the energy content and say that it is by far the most efficient thing to take, and that argument is strong. And most researchers working on this find it persuasive. That is still an inference about motive drawn from the outcome. Nobody has been inside the decision. There are other possibilities floating around that deserve to be named rather than ignored. Shark muscle is loaded with urea and related compounds, part of how sharks manage the salt balance of their bodies, and the flesh is chemically unpleasant in ways that might make it a poor meal regardless of its calorie content. Whether that is a factor, a minor detail, or irrelevant is not settled. It is also unclear whether the behavior was invented once and spread, or arrived independently in different oceans because the same solution keeps presenting itself to any predator smart enough to look. Both are plausible. Neither is proven. What is not in question is the outcome. Something is opening the ocean's most celebrated predator like a package, removing the one component that is worth the most, and swimming away from the rest. And that raises the question the whole thing turns on, the one that should have been bothering you since the beginning. How do you hold a great white shark still long enough to do that? Because none of this works on a fighting animal. A 4-meter white shark thrashing at close range is capable of doing serious damage to whatever is holding it. Even a 2.5-meter juvenile is a large, heavily muscled, armed animal. The liver extraction requires the shark to be positioned, opened at a specific place on its underside, and kept there while the organ is taken. That is not something you do to something that is resisting, unless you can turn the resistance off. Flip a shark onto its back and something extremely strange happens. It stops. The muscles relax. The body goes limp. Breathing becomes slow and rhythmic. The animal stays that way, upside down, unresponsive, for anywhere from a few seconds to several minutes, and then comes out of it and swims off as if nothing occurred. Researchers have used this for decades as a handling technique because a shark in that state can be worked on with far less risk to the shark and to the people involved. It has a name: tonic immobility. What it actually is remains poorly understood, which is worth saying plainly rather than papering over. The usual description is that inverting the animal scrambles its orientation and triggers a reflexive shutdown, and there are various ideas about which nervous pathways are doing it and why it should exist at all. Some species show it strongly, some weakly, some not at all. The honest position is that this is a real, repeatable, documented physiological response whose function nobody has fully explained. Now think about what that response means for a white shark specifically, because for this animal, it is not simply an odd trick. A white shark cannot pump water over its gills the way many bottom-dwelling sharks can. It breathes by moving. Water enters the open mouth as the animal swims forward, passes across the gills, exits the gill slits, and that flow is generated entirely by forward motion through the water. Stop the shark and you stop the flow. Stop the flow and you stop the oxygen. So invert a white shark and you get two things simultaneously. The muscles stop working and the breathing stops working, because the breathing was never independent of the swimming in the first place. The animal is not merely paralyzed. It is suffocating while paralyzed. And this is exactly what has now been filmed. In the Gulf of California off Mexico, researchers documented killer whales attacking juvenile white sharks and doing precisely this. In an event recorded in August 2020, 5 killer whales pursued a young white shark, pressed it toward the surface, and worked together to turn it onto its back. They took it down and came back up with the liver. They then repeated the process on a second juvenile shark shortly afterwards. 2 years later, in August 2022, a similar attack was observed. 5 whales pushing a juvenile white shark inverted and bringing it to the surface, bleeding from the gills, with the liver exposed. The findings were published in Frontiers in Marine Science in 2023, Mobi Sanchi 25 Halaki Yo 25. The aerial footage from those events is what makes this so difficult to explain as coincidence. The strikes are consistent. The positioning is consistent. The sharks end up in the same orientation, and the same organ comes out, and the meat is shared among the group. But, and this matters, we still cannot say for certain that the whales are deliberately inducing tonic immobility because they understand what it does. That distinction is not academic. There is a version of this where the whales have identified a physiological switch in a dangerous animal and are pressing it on purpose. And there is a version where inverting the shark is simply the most practical way to get at its soft underside, and the paralysis is a bonus nobody planned. The observed behavior is compatible with both. Researchers have argued for the first because of the consistency, and because the whales appear to be positioning rather than wrestling, and that reading is reasonable. It is still a reading. The uncertainty there is more interesting than a clean answer would be, so it is worth leaving open. Either way, the practical result for the shark is identical, and it is the worst possible result. The counter is not a behavior. It is a body state. That is the sentence that should land hardest in this whole story. A shark could, in principle, learn to avoid a place. It could, in principle, adjust when and where it hunts. What it cannot do is opt out of its own reflexes. Tonic immobility is not a decision the shark is making badly. It is a response wired into the animal below the level of anything it controls. And the requirement to keep moving in order to breathe is not a habit. It is anatomy. There is no version of a white shark that trains its way out of needing forward motion to get oxygen. So the most dangerous fish in the ocean has a hard-coded vulnerability that it cannot patch, and something has found it. Given all of that, the shark's behavior starts to look less like cowardice and more like the only sane option available. Which brings us back to the empty water. On the 4th of October, 1997, biologists working at the Farallon Islands off San Francisco watched something nobody had documented before. 2 killer whales attacked and killed a white shark near the islands. One of the whales was observed carrying the shark, and after several minutes, a portion of the liver came free. The event was witnessed, filmed, and recorded, and it was the first clear documentation of killer whales preying on white sharks. Then came the part nobody was expecting. The Farallones in autumn are one of the most reliable white shark aggregation sites on Earth. Elephant seals haul out there, the sharks arrive on schedule to hunt them, and researchers have been counting attacks from the island for decades. It is a system with rhythm. After that single killing, the sharks left. Not the one that was attacked, obviously. The others. The whole aggregation cleared out of the area early, and the seal predations that normally define the rest of that season essentially stopped, dropping by around 95% for the remainder of the year. 1 kill, 1 afternoon. An entire season of hunting abandoned by animals that were not touched. For a while, that could be filed under freak occurrence. 27 years of surveys and a great deal of tagging later, it could not. A study published in Scientific Reports in 2019 pulled together long-term survey data from southeast Farallon Island with tracking data from 165 white sharks tagged between 2006 and 2013, and looked at what happened when killer whales showed up. The pattern held. Killer whales appeared, sometimes only briefly, sometimes apparently just passing through. The white sharks left, often within hours. They did not return that season. Annual counts of shark attacks on seals dropped in the years when close encounters with killer whales occurred, and the tagged animals showed where they went. Sharks that vacated the Farallones turned up at other aggregation sites, with detectable increases in shark density at Año Nuevo Island. They did not disperse into open ocean at random. They relocated. That distinction matters more than it looks. A panicked animal scatters. These sharks move to other known feeding grounds, which is the behavior of an animal making a trade rather than an animal fleeing blindly. South Africa produced the same result on a much larger timescale. Following the predation events that began at Gansby in 2017, researchers combined sightings data corrected for how much time boats actually spent on the water with telemetry from tagged sharks. White sharks left the area after the killings, and they left again in response to further sightings of the same pair of killer whales and of other killer whale groups in the vicinity. Sightings at a site where white sharks had been close to guaranteed stayed depressed for roughly 2.5 years. 2.5 years at a site where the sharks had been a fixture. And into that gap moved other animals. Bronze whaler sharks, previously kept at the margins, became more common in the space the white sharks had left. Now here is the part where the story gets complicated. And it should, because the simple version has started to be used as an explanation for everything. In February 2026, a study in wildlife research went back to South Australia's Neptune Islands, another major white shark aggregation site, and asked a harder question. A killer whale predation event occurred there in 2015, and it was followed by a long absence of white sharks. The obvious conclusion was drawn. The researchers then took 12 years of acoustic telemetry and tourism sighting records and tested whether that long absence was actually exceptional or whether it fell inside the range of things white sharks do anyway. The answer was uncomfortable for the neat version. Killer whales can trigger an immediate departure, and that part is solid. Extended absences, though, also occur naturally at that site without any killer whales involved. And not every encounter produced a long absence. A killer whale sighting in October 2024 was followed by a departure of about 5 days. The death of a tagged white shark was followed by an absence of about 4 days. 5 days. Not 5 months. So the picture that emerges is more interesting than the headline. The immediate response is real and fast, and repeated across 3 continents. The duration of that response is highly variable, and attributing every long white shark absence to killer whales is not supported. Sharks leave sites for many reasons: prey moving, water temperature shifting, seasonal migration, fishing pressure, and reasons we have not identified. Keep both halves. The flight is real. The bookkeeping is messy. There is also an open question underneath all of it that nobody has closed. How does a white shark know? We do not actually know what the cue is. It could be sound, since killer whales are extremely vocal in some contexts, and a shark's hearing is tuned to low frequencies that travel well underwater. It could be chemical, with sharks detecting something in the water associated with the whales, which would fit an animal whose sense of smell is one of its primary long-range tools. It could be that the sharks are detecting the chemical signature of a dead shark, which is a very different thing from detecting the predator itself. It could be an innate response to a specific stimulus, or it could be learned by individuals that survived an encounter, or it could be some combination. Each of those possibilities implies a different animal. A shark that flees an innate cue is running a hardwired program. A shark that flees because it learned something is doing something we have not credited sharks with. There is no consensus, and anyone who tells you there is has skipped a step. What can be said is that the response is disproportionate to the threat in a way that tells you something about the animal. Killer whales do not kill many white sharks. The documented events are not common. The whales pass through, sometimes without killing anything at all, and the sharks clear out regardless. That is not a response to actual mortality. That is a response to risk, and it is the same logic every prey animal on Earth runs. The cost of being wrong once is total. The cost of leaving is a season of food. So the shark takes the smaller loss, and that is the correct decision. That needs saying, because the framing of a great white shark running away invites a certain amount of mockery, and the mockery is misplaced. There is no version of this fight that the shark wins. Its entire arsenal is built around ambushing an animal that does not know it is there. Against a coordinated group of large, fast, acoustically linked predators that can find it, corner it, and switch off its nervous system, the shark has nothing to deploy. Fighting is not brave. Fighting is fatal. Leaving is the only move on the board, which leads directly to the next problem, and it is the one that actually threatens the species rather than the individual. What does leaving cost? For most animals, a lost season is survivable. Miss the food? get thin, come back next year, breed anyway. That works for animals that breed fast and often, that produce large numbers of offspring, that can absorb a bad year because there are plenty more coming. The white shark is close to the opposite of that in every dimension. Start with how long it takes to become an adult. Estimates vary by region and by method, and this is genuinely contested territory. But males are generally thought to reach maturity somewhere around a decade of age, and females considerably later, commonly estimated in the range of 12 to 18 years, and by some estimates later still. Take the middle of that, and you have an animal that spends more than a decade of its life as a juvenile before it contributes a single offspring. A decade is a long time to be a juvenile in an ocean that includes killer whales, larger sharks, fishing gear, and nets. Then look at reproduction, which is where the white shark stops resembling a fish at all. Gestation is estimated at roughly 12 to 18 months. That alone is longer than most large mammals. And what happens inside that time is grim in a way that is easy to describe and hard to forget. White shark embryos are not fed by a placenta. They develop inside the mother, and once they exhaust their own yolk supply, they begin eating unfertilized eggs that the mother continues to produce, a strategy called oophagy. Research on lamnoid sharks indicates the embryos are taking on substantial quantities of lipid this way, packing on fat before they are ever born, which is why pups emerge already large, around 1 meter to 1.5 meters. So the mother is not carrying young. She is manufacturing food for them internally for over a year, converting her own energy reserves into a small number of very large, very well-provisioned offspring. The litter is small. Reported ranges commonly run from a couple of pups up to around 10, with higher numbers occasionally suggested. Compare that to a bony fish of comparable size releasing millions of eggs in a season, and the strategy becomes obvious. The white shark is not playing a numbers game. It is making a handful of nearly finished predators and betting on quality. And after that pregnancy, there is very likely a recovery period before she can do it again. The interval between litters is not well established, which is itself a problem, but it is generally thought that these animals do not reproduce every year. Put the whole life history together, and you get something that looks less like a fish and more like a large, slow mammal. Late maturity, long pregnancy, few young, long gaps. Long life with bomb radiocarbon work on vertebrae suggesting white sharks can live for decades. One large male estimated at over 70 years. Now bring the killer whales back into that. An individual shark that abandons a hunting ground for a season loses the fat it would have put on. That fat is not decoration. In an animal that pays a constant metabolic bill just to stay warm, and that stores its energy reserve in the same organ that keeps it from sinking, condition is directly tied to whether it can migrate, whether it can reproduce, and whether a female can afford to convert a year of her own energy into a litter. Reproduction in a species like this is not automatic. It is funded. So a displacement is not a bad afternoon. It is potentially a missed breeding cycle in an animal that only gets a limited number of them, and that already takes over a decade to get to the first one. Here is where the caution flag goes up, because this is exactly the point where a story like this usually starts inventing consequences. Nobody has demonstrated a population-level collapse of white sharks caused by killer whales. That has not been shown. The documented effects are local and behavioral. Sharks leave sites. Sharks redistribute. Sharks sightings at specific locations drop. Whether that translates into fewer sharks overall, or simply the same sharks somewhere else, is an open question that the data currently cannot answer. What can be said with confidence is structural. A species that reproduces on this schedule has almost no capacity to absorb repeated pressure. It cannot respond to a bad decade by producing more sharks. The machinery does not run faster. Whatever else is true, the white shark is an animal with a very long recovery time and no way to shorten it. And that is the deeper asymmetry hiding inside this entire story, because the killer whale's relationship with time runs in the opposite direction. The white shark's long life buys it nothing but more life. The killer whale's long life buys it something else entirely. Consider a fact about killer whales that is genuinely bizarre, and that gets mentioned far too casually, given how rare it is in the animal world. Female killer whales stop reproducing decades before they die. In the vast majority of animals, reproduction continues essentially until the end. An animal that survives is an animal that breeds, and natural selection has very little interest in what happens to a body after it stops producing offspring. Menopause, in the sense of a long post-reproductive life, is close to non-existent in the animal kingdom. It shows up in humans, and in a small handful of toothed whales, and that is more or less the list. Female killer whales in some populations stop calving in their 30s or 40s, and can then live for decades more. That is a large fraction of a lifespan spent alive, healthy, socially central, and reproductively finished. From a pure gene-counting perspective, that should not survive. Those decades are expensive. She still eats. She still takes up space in a group that has to feed itself. Whatever is keeping her there has to be paying for itself somehow. Research published in Current Biology in 2015. Fauci went looking for what she is doing with that time, and the answer reframes the entire species. The study examined resident fish-eating killer whales in the northeastern Pacific and looked at who leads group movements while the whales are foraging for salmon. Post-reproductive females were disproportionately likely to be out front, leading the group's collective movement. That on its own could be explained a dozen ways. The next part cannot. The effect was strongest in the years when salmon were scarce. When food was abundant, leadership by old females mattered less. When the fish were hard to find, the group followed the oldest females more. That is precisely the signature you would expect if what the old female is carrying is not authority, but information. Knowledge of where the fish go in a bad year, which channel still holds them, which route worked the last time conditions looked like this. In a good year, anyone can find salmon. In a bad year, you need someone who remembers the last bad year. The same work found that these females were more likely to lead their sons than their daughters, which fits models of how menopause could evolve through the specific way killer whale families are structured, with sons remaining permanently attached to the mother. The implication is hard to overstate. A post-reproductive killer whale is not a spent animal being carried by the group. She is the group's memory of rare events, decades of accumulated information about a coastline, condensed into an animal that can be followed. Nothing in this story has an equivalent to that. The white shark's biology is remarkable, and its life is long, and it can cross entire oceans, and none of that produces anything that outlives the individual. Every white shark alive today started with nothing and will end with nothing transferred. The species' knowledge is entirely contained in its genome, which means it updates at the speed of evolution, which means centuries at best. The killer whale has a second inheritance system running alongside the genetic one, and that one updates in years. Consider what that means when a new tourist. I bet it means when a new opportunity appears. If a food source shifts, if prey moves into new water, if a new species becomes available, the shark can only respond with the body it has. It might follow prey. It might change where it swims. It cannot change what it is capable of doing when it arrives. A killer whale population can develop an answer, refine it over a few seasons, and pass it to animals that will still be alive in 50 years. And there is evidence that this is happening right now in real time, with white sharks as the target. The Gulf of California events are the clearest window into it. The whales documented there attacking juvenile white sharks are not random individuals passing through. They belong to a group associated with a particular male, And the same technique appears across events separated by years, with young animals present. Researchers looking at that footage have raised the possibility that the technique is being transmitted within the group, which is exactly what you would expect if this is culture rather than coincidence. That claim should be held carefully. Establishing teaching in the strict sense in wild animals is extremely difficult, and observing a technique repeated across a group is not the same as observing it being taught. The reasonable position is that the pattern is consistent with social transmission and that the alternative, every animal independently discovering the same procedure, is a harder thing to believe. Either way, the direction of travel is one way. The technique exists. It is getting faster. It has appeared in South Africa, in Australia, in Mexico, in California. And there is no mechanism by which white sharks develop a counter, because there is no mechanism by which white sharks develop anything within a lifetime and keep it. Which brings this to the assumption that has been quietly sitting underneath the entire story. And it is worth breaking because it is wrong in a way that changes what the phrase apex predator even means. The assumption is that being at the top means eating everything. Killer whales are the most widely distributed mammal on the planet after humans. They are in the Arctic and the Antarctic and the tropics and everywhere in between. There is essentially nothing in the ocean they are not physically capable of killing. Reading that, the natural conclusion is that they are generalists, taking whatever the ocean offers. They are not. They are among the most extreme specialists in the ocean, and that is precisely why they are dangerous. Individual killer whale populations eat narrow diets. Some eat almost exclusively fish, and within that some are effectively locked onto a particular species of salmon. Some eat marine mammals and will not touch fish. Some target herring. Some hunt whale calves, and some have gone after cartilaginous fish specifically, which is the part of this that should make anyone paying attention sit up. Around New Zealand, killer whales are known to specialize heavily on rays and sharks. They work shallow bays and sandy bottoms, dropping down onto the seafloor to find rays that are lying flat and buried, and taking them off the sand. That is not opportunistic feeding. Finding a buried ray requires knowing where to look, and handling one requires dealing with an animal that carries a barbed spine on its tail and will use it. Those whales have been recorded flipping rays over before feeding on them, which is the same maneuver, on a smaller animal that shows up in the white shark attacks on the other side of the world. Sit with that for a second. There is a killer whale population whose entire job is hunting elasmobranchs, the group that contains sharks and rays, and it developed a handling technique built around turning them upside down. Whether the white shark behavior in South Africa, Australia, and Mexico is related to that, or arrived independently, is not established, and it would be irresponsible to claim a connection. What it does tell you is that the general solution is not exotic. Once a killer whale population starts working on cartilaginous fish as a category, the inversion trick appears to be one of the things that gets found. In the Antarctic, the divisions run even deeper. Researchers there distinguish multiple forms of killer whale that differ in size, in the shape and extent of their pale eye patches, in their coloration, in where they spend their time, and in what they eat. Some work the pack ice for seals. Some target penguins and fish. Some concentrate on minke whales. They are not casually different. They are different enough that their status as separate populations, or something closer to separate species, has been an active argument in the literature. None of those diets are preferences that shift with the season. They are identities maintained across generations, reinforced by the fact that each group's entire toolkit, its hunting technique, its group size, its acoustic behavior, its movement patterns, has been optimized around one kind of prey. That is why the techniques are so good. You do not get wave washing from a generalist. You do not get intentional beaching from an animal that hunts a bit of everything. You get those things from populations that have been doing one job in one place for a very long time, refining it and passing the refinement forward. Specialization plus cultural transmission is the combination. Either one alone is ordinary. Together, they produce a predator that keeps getting better at a specific problem without waiting for its body to change. And now the honest complication, because this is not a story where one animal is simply superior. That specialization is also a trap. A killer whale population that is culturally locked onto one prey type has a serious problem when that prey disappears. The fish-eating residents of the northeastern Pacific are strongly dependent on particular salmon runs, and those runs have declined. The whales have not simply switched to seals. Despite swimming past seals constantly, despite being physically capable of killing them, despite other killer whales in the same water doing exactly that, the behavioral separation holds even when it hurts. Read that again because it is the mirror image of everything this story has been building. The thing that makes killer whales so effective, a body of learned, transmitted, specialized knowledge, is also a thing that can be wrong. Culture is inherited. Inherited things can become outdated. A technique perfected for a world that is changing is a technique that can strand the animals carrying it. So the difference between these two predators is not that one is flexible and one is rigid. Both are specialists. Both are locked in. The difference is where the lock is. The shark's specialization is written into its anatomy. It is in the shape of the teeth, the placement of the muscle, the plumbing of the heat exchangers, the geometry of a body built to come up from below at speed. None of that can be revised. A white shark cannot decide to be a different kind of predator. It cannot try something else next season. Its strategy and its skeleton are the same object. The killer whale's specialization is written into behavior, and behavior sits on top of the body rather than inside it. It can be altered without altering the animal. It can be lost. It can be replaced. It can be improved by a single individual and then copied. One of these predators is a finished product. The other is still in development. That gap widens further once you look at how each animal collects information about the world, because the two of them are not even operating on the same principle. Everything the white shark does is receiving. Every sense it has waits for the world to send something. Smell waits for molecules to drift down current. The lateral line waits for a pressure wave to arrive. The eyes wait for light to bounce off something. The electrical sense waits for a living body to leak a field into the water nearby. It is a magnificent set of receivers, arranged in a handoff sequence from kilometers away down to contact range. And every single one of them is passive. The shark cannot ask a question. It can only listen for an answer that something else happened to send. That works beautifully against prey that does not know it is being watched. It works badly against anything that can control what it emits. The killer whale does the opposite. It transmits. A killer whale produces rapid clicks and listens for the echoes coming back. And from the timing and the shape of those returns, it builds a picture of what is in front of it. It can do that in complete darkness. It can do that in water so turbid that vision is useless. It can do it while the target is doing nothing at all, because the whale is not waiting for the target to reveal itself. The whale is illuminating it. Stack those two systems against each other in an encounter, and the asymmetry is severe. The shark is trying to detect an animal that is actively scanning for the shark. One of them chooses when to look. The other can only hope not to be noticed. Sound in the ocean makes that worse, in a way that is easy to miss because human intuition is built for air. Sound travels through seawater at roughly 4.5 times the speed it travels through air, and it carries far better. Light, meanwhile, is almost useless, past a few tens of meters in coastal water thick with plankton. In that environment, an animal that hunts with sound is operating with a sense that reaches out over enormous distance, while an animal that hunts with sight is effectively working inside a small bubble. And then there is the thing the shark does not have at all. The white shark cannot make a sound. Not a call, not a click, not a warning. It has no mechanism for producing one, and there is no evidence of any acoustic signaling in the species. Whatever a white shark knows, it knows alone, and there is no way to tell another shark anything. There is no alarm. There is no coordination. There is no way to say the thing that killed my season is over there. Killer whales are the opposite case again, and not in a vague way. Different killer whale groups use different sets of calls. Those call repertoires are stable over long periods, they differ between pods, and closely related groups share more of them than distant ones. Researchers use them to identify who is who from a hydrophone without ever seeing the animals. Calves acquire the calls of their own group. A shared, learned, group-specific vocal system is the infrastructure culture runs on. It is what makes a 5-animal operation on a moving target possible at all. Wave washing does not work if the whales cannot synchronize. Herding a herring school does not work if nobody can signal. So on one side you have a solitary, silent animal running passive sensors and a single hunting routine it was born with. On the other, you have a group of animals that can scan actively, talk continuously, hold different roles, and adjust the plan while it is happening. That is not a fight. It is a category difference. Now, it would be easy to stop here and declare the killer whale simply better. And that conclusion is lazy and, more importantly, wrong. The orca is not free. Everything it has is paid for, and some of the bills are brutal. The most obvious one is air. A killer whale is a mammal that lives in the sea and cannot breathe in it. Every single individual, every day of its life, has to return to the surface or die. There is no exception, no adaptation that gets around it, no deep refuge. That constraint shapes everything: how deep it can hunt, how long it can stay, how it sleeps, how it handles ice, what happens to a calf that gets separated in rough water. The shark has no such ceiling. A white shark can drop into deep water and stay there. Tracking of white sharks has shown them making long offshore migrations and diving to substantial depths, spending long periods in cold, dark water far from any coast. There is nowhere in the upper ocean it must return to. Then there is the cost of the childhood. The killer whale's greatest advantage, that a calf grows up beside animals that already know how to hunt, has a price attached, and the price is that the calf is useless for years. Killer whale gestation runs to roughly a year and a half. Calves nurse for a long time and stay with the mother essentially permanently in some populations. That is an enormous investment of energy and risk in a very small number of offspring, and calf mortality in the first year is high in the populations that have been studied closely. So the killer whale is running the same slow reproduction gamble the white shark is running. With an added requirement, the offspring has to survive long enough to be taught, and the teachers have to survive long enough to teach, which exposes the real fragility in the whole system. Culture is stored in individuals. Kill the individuals, and the culture goes with them. If a population loses its oldest females, it does not simply lose some animals. It loses the memory of the last time salmon failed. It loses the route that worked in a bad year. It loses whatever refinement of a hunting technique took 30 years to develop, because that refinement was never written down anywhere except in a body that has now stopped swimming. Genetic information survives the death of individuals by definition. Learned information does not. That makes a culturally specialized predator far more vulnerable to sudden losses than its ecological position suggests. A species can be at the top of the food web and still be one generation away from forgetting how it got there, and it is not hypothetical. The whales that concentrate on specific salmon runs have not been able to shift when those runs failed. Whatever is holding them to that diet, it is strong enough to override the availability of other food swimming past them. So put the two predators next to each other honestly. The white shark is a solitary, silent, passively sensing, anatomically committed hunter with an outstanding body, no capacity to learn from others, no ability to update, no way to warn or be warned, and no counter to a coordinated attack. It has almost no ceiling on where it can go, and no floor under how much it can lose in a season. The killer whale is a social, vocal, actively sensing, culturally committed hunter with an ordinary mammalian body, a spectacular capacity to accumulate technique, an absolute dependence on surfacing for air, a slow and expensive reproductive cycle, and a body of knowledge that can be erased by the deaths of a handful of old animals. Neither one is invulnerable. They are vulnerable in completely different places. And that difference explains the one thing this whole story keeps circling back to, which is why the shark runs rather than fights, and why running is not a small event. Because when a predator that large leaves a place, the place changes. This is the part of the story that stops being about two animals. A large predator does not only affect an ecosystem by eating things, it affects it by being there. The threat itself reorganizes the behavior of everything below it, and that reorganization can matter more than the kills. Watch a Cape Fur seal colony, and you can read the shark's presence in what the seals do, even on days when no shark is seen. They leave the island at particular times. They cross the dangerous open water in groups, rather than alone, because a lone seal at the surface is exactly the target the shark has been shown to prefer. They move fast through the deep water near the island and slow down once they are past it. They avoid certain approaches. Young animals, the ones with the least experience and the least speed, are the ones that get caught, which means every generation of seals is shaped by the ones that did not make it back. None of that is the shark eating. That is the shark existing, and the seals living around the shape of the risk. The same is true one level down. Seals eat fish. Where seals feel safe, they feed hard. Where they do not, they feed less, or feed elsewhere, or feed at different times. So the shark's presence reaches down past the seal and into the fish population that the seal is eating, without the shark ever touching a fish. Remove the shark, and you are not subtracting one animal. You are removing a constraint that has been holding the behavior of everything underneath it in a particular shape. That is not a theoretical claim. It has now been watched in one of the best studied pieces of coastline in the world. False Bay, on the western side of South Africa, was for years the place people went when they wanted to be certain of seeing a white shark. Seal Island sits in the middle of it, packed with Cape Fur seals, and the sharks worked it hard enough that the breaching attacks there became internationally famous. Researchers documented the hunting, the timing, the success rates, the seasonal rhythm. The system was well characterized. In mid-2018, the sharks stopped appearing. Not fewer sharks, not a poor season. They went to essentially zero and stayed there. The immediate temptation is to blame the killer whales, because port and starboard had become notorious by then, and the timing is suggestive. That explanation is not adequate on its own, and this is where the story has to be careful, rather than dramatic. Several pressures were acting on False Bay's white sharks at the same time. Nets and gear deployed along that coastline over decades, intended to reduce the risk of shark encounters for swimmers, killed white sharks steadily and quietly for a very long time. Fisheries removed enormous quantities of the smaller sharks that white sharks feed on, particularly during their juvenile years, which is the phase where a young white shark is not yet big enough to be taking seals. And killer whale predation entered the picture in the same period. You cannot separate those cleanly. What you can say is that a population that had already been ground down for decades encountered a new source of pressure, and something broke. Researchers who worked on the False Bay decline have pointed to that combination, rather than to any single cause, and the honest version of this story keeps it that way. What happened afterwards is where it becomes genuinely unsettling, because the bay did not simply become a quieter place with fewer sharks in it, it reorganized. A study published in Frontiers in Marine Science in March 2025, drawing on more than 2 decades of data, tracked what followed the loss of white sharks from False Bay. And the pattern moved down the food web in a chain that is almost textbook, and almost never actually observed this cleanly in the ocean. Cape fur seals increased. That is the first and most obvious consequence. And it is exactly what you would predict when the animal that has been eating your young and dictating your movements stops showing up. The seals were released. Broad-nosed 7-gill sharks increased. That one is more interesting because it had already been noticed. 7 gills are a large, blunt, slow-looking shark that had historically kept to specific areas, and after the white sharks declined, they began appearing in numbers in the kelp forests of False Bay, where they had not previously been a fixture. Work published in 2019 described that emergence, an apex predator moving into a space that had opened up. They were not replacing the white shark exactly. They were taking the room it had left. Then the effects went downward. The fish species that Cape fur seals feed on declined. More seals, feeding harder, in water where they no longer had to spend energy managing the risk of being ambushed, is a heavier load on the prey population underneath them. And the smaller sharks that 7 gills feed on declined as well. A second predator released into a space it had not previously dominated, pressing on species that had not been experiencing that pressure. So a single missing animal produced increases at one level and declines at 2 others, and the effects were still spreading when the study was written. Sit with the shape of that for a moment. The white shark's role in False Bay was not that it ate a lot of seals. In terms of raw numbers, its predation was not what was holding the seal population in check. Its role was that it made the water dangerous, and danger changes behavior, and behavior is what determines who eats how much of what and where. Take away the danger, and the entire structure slackens. Counting stomach contents misses almost all of it. The important consequences of a top predator are frequently not in what it kills, but in what it prevents, and prevention is invisible until it stops. Gansby showed a smaller and faster version of the same thing. After the white sharks left, following the killer whale predations there, the space did not stay empty. Bronze whaler sharks, which had been present but subordinate, became more common. That is not a replacement in any meaningful ecological sense because a bronze whaler does not hunt the way a white shark hunts and does not exert the same pressure on the same animals. It is a different predator doing a different job in the same water. What both cases demonstrate is that these systems do not tolerate a vacancy. Something moves in. And the something that moves in has its own diet, its own preferences, its own effects, and no obligation to reproduce the pattern that was there before. Which turns the killer whale into something more than a predator that occasionally kills a shark. If a small number of whales present for a short time can push an apex predator out of a region for months or years, then the whales are not only removing individuals, they are functioning as a switch on the entire local food web. Their presence, on its own, without a single additional kill, is enough to change who dominates a coastline. That is an extraordinary amount of leverage for an animal that might pass through in an afternoon. And it puts the flight response in a different light. The shark leaving is not a footnote to the encounter. The shark leaving is the main event, ecologically speaking. The kill is almost incidental. What matters is the fear, and how far it travels, and how long it lasts. Which returns us to the question that has been sitting unanswered underneath all of this. If the response is that strong, and the consequences are that large, Why has this been so hard to see? The answer is that the ocean is very good at hiding its own events, and almost everything about this particular interaction is designed to be missed. Start with the basic problem. Two animals meet in open water with no witnesses. The encounter lasts minutes. There is nothing solid nearby, no vantage point, no fixed camera, nobody scheduled to be there. The odds that a human being is present looking in the right direction at the right moment in water clear enough to see anything are close to zero. Multiply that by how rarely the encounter happens in the first place, and you get an event that could occur regularly for millennia without being recorded once. Then there is what happens to the evidence. A dead white shark does not float. It has no swim bladder, and the organ that provided its buoyancy has just been removed, which means the carcass goes down. It sinks into deep water and is consumed by scavengers within days. Almost every one of these kills leaves nothing at all. The bodies that washed ashore in South Africa are the exception, not the rule. And they only became a signal because several of them arrived in the same region in a short period, and somebody was paying attention to the pattern rather than to the individual animals. Think about what that means for the historical record. If this behavior has been happening for a long time, in multiple oceans, at low frequency, with the physical evidence disappearing into deep water almost every time, then the absence of old reports is not evidence of absence. It is evidence that nobody could have seen it. And the old picture was built on exactly that gap. For most of the time, people have been thinking seriously about white sharks. The reasonable conclusion from available evidence was that nothing hunted them. Nothing had been observed doing it. No carcasses were turning up with predator wounds. The animal was large, fast, armed, and warm-blooded, and there was no reason to think anything was killing it. Calling it an apex predator with nothing above it was not a failure of imagination. It was the correct reading of what had been found. That picture did not collapse because someone thought harder about it. It collapsed because the tools changed. 3 technologies did most of the damage, and each one opened a different window. The first was electronic tagging. Once you can attach a device to a shark and know where it is for months or years, you stop relying on sightings, which only tell you where people happen to be looking. Tagging is how anyone could say with confidence that sharks left the Farallones within hours of killer whales arriving and turned up somewhere else. Tagging is why the Gansby displacement could be measured rather than guessed at. It is also how the more skeptical work at the Neptune Islands became possible, because 12 years of acoustic detections lets you ask whether a long absence is unusual or normal, which is a question nobody could have answered from a boat. Tagging converted an anecdote into a time series. That is the single most important thing that happened to this field. The second was the drone. The reason the Gulf of California footage exists at all is that a camera can now be put 50 meters above an event, in position, in seconds, from a small boat, by researchers who are not in the water. Almost all of this behavior happens in the top few meters of the ocean, which is exactly the layer that is nearly impossible to observe from a vessel and trivially easy to observe from above. Surface events that would have been a confusing patch of white water and a few fins in 1995 are now a clear overhead view of 5 animals holding a shark in a specific orientation. An enormous amount of what we now know about killer whale hunting technique came from that change in vantage point, and it happened fast. The behavior was not new. The angle was. The third was genetics. The Australian carcass is the cleanest illustration. A wound is an interpretation. Somebody looks at a bite and estimates what made it, and other people disagree, and the argument continues indefinitely because there is no way to settle it. Swabbing that wound and sequencing what is in it removes the argument entirely. The killer whale DNA was in the major bite. The 7-gill DNA was in the others. That is not an interpretation of a shape. That is the identity of the animal whose mouth was there. The same approach turns other ambiguous carcasses into data, and it means that the next 20 years of this question will be answered very differently from the last 20. So the correction did not come from a smarter idea. It came from being able to see. That is worth holding on to, because it is the actual shape of how this kind of science moves. Nobody was hiding anything. Nobody was foolish. The old model was a completely rational summary of a world that could not be watched closely enough, and it broke the moment the watching improved. And the thing that broke was not a fact about sharks. It was a definition. The phrase apex predator carries an implication that is not actually part of the term, that being at the top means nothing can touch you. That is not what an apex predator is. It is a description of position in a food web, and food webs are not tournaments. Being at the top means most of your energy comes from eating other consumers rather than from grazing, and that is all it means. It is not a claim of invincibility, and it never was. The white shark's position was never wrong. What was wrong was the story people wrapped around it. Because when you look at what actually determines the outcome when these two animals meet, none of the qualities that made the shark famous appear anywhere in the list. Not size, since a single killer whale did the job on a juvenile in under 2 minutes, and groups of them have taken larger sharks. Not bite force, since the shark never gets to use it. Not speed, since speed is only useful against something that has not already positioned itself around you. Not sensory capability, since the shark's magnificent receivers were built to detect prey that does not know it is hunted, not to detect a hunter that is scanning for the shark. What determines the outcome is who has better information and who can act on it together. That is the whole contest, and the shark does not have an entry in either category. There is one more question hiding in all of this, and it is the one that is hardest to answer, which is usually a sign that it is the interesting one. Is this new? The behavior has only been documented recently, and it appears to be spreading. And it is tempting to describe it as an innovation, a technique that killer whales invented in the last few decades and are now teaching each other. The Gulf of California work has raised the possibility that shifting ocean conditions are moving juvenile white sharks into water where these particular whales encounter them more often, which would make this at least partly a story about a changing ocean creating a new opportunity. There is a counter-argument sitting in plain sight, and it comes from the sharks themselves. Look at how fast they run. A white shark does not investigate. It does not hesitate. It does not approach, assess, and then withdraw. In the best documented cases, the sharks were gone within hours. And at some sites, they stayed gone for periods that make no sense as a response to a one-off surprise. The response is immediate, total, and disproportionate to the number of sharks actually killed. That is not what a novel threat looks like. Novel threats produce curiosity, or clumsy responses, or delayed responses, or no response at all. Animals encountering something genuinely unfamiliar tend to handle it badly, which is precisely why introduced predators are so devastating to species that have never faced them. A hair trigger, all-or-nothing avoidance response is what you see in an animal that has been dealing with a threat for a very long time, which would mean the relationship is old and only the observation is new. That interpretation has to stay an interpretation. Nobody can demonstrate how long killer whales have been killing white sharks, because the evidence sank. What can be said is that the shark's reaction is far too fast and far too complete to be a first draft, and that an animal does not usually develop that kind of response to something it has just met. There is also a third possibility that is less satisfying and probably closer to the truth, that the relationship is old, that the technique for exploiting it is refined and regional and still developing, and that both statements are true at once. An ancient threat plus a modern specialization in specific populations, spreading. Either way, the shark is on the wrong side of it, and the reason is the same reason it has been on the wrong side of it all along. It cannot participate in the arms race. That phrase gets used loosely in nature documentaries, predator and prey pushing each other to improve, and it is usually describing something that happens over evolutionary time. Prey gets faster, predator gets faster, across thousands of generations. Both sides are moving, slowly, through their bodies. That is not what is happening here. One side is moving through bodies. The other side is moving through behavior, and behavior moves several orders of magnitude faster. To appreciate the size of that mismatch, consider what it would actually take for white sharks to develop a counter to this. A shark would have to survive an encounter. Then it would have to reproduce. Then whatever trait helped it survive would have to be heritable, and the offspring carrying it would have to survive a decade or more of juvenile life before breeding themselves. Repeat that across many generations with a species whose females may not mature until their teens and may not breed every year, and you are looking at a response time measured in centuries. Minimum. A killer whale population can modify a technique between one season and the next, and the animals that learn the modification will still be hunting in 50 years. Calling that a competition is generous. Those are two completely different clocks, and one of them ticks so much faster that the other might as well be frozen. And it is worth being precise about why the shark's clock runs so slowly, because it is not a flaw. It is the direct cost of being what it is. The slow clock comes from the same place as the shark's power. Big bodies take time to build. A predator that hunts by delivering an enormous single strike has to be large, and large means slow growing, and slow growing means late maturity. A predator that lives in cold water on a warm-blooded metabolism has to eat a great deal, which means it has to invest years in reaching the size where it can take high-value prey. A predator that produces offspring capable of surviving alone from birth has to load each one with an enormous amount of energy, which means it can only produce a few. Every one of those is a consequence of the same design decision. Build a lone hunter that needs no upbringing, no group, no teaching, and no support, and you get an animal that is completely self-sufficient the moment it is born and completely incapable of ever being improved. The killer whale made the opposite bet. Build an animal that is helpless for years, dependent on adults, expensive to raise, unable to survive alone, and locked into a social group for life. And in exchange, you get an animal that can inherit everything the previous generation figured out. One strategy front-loads competence, the other front-loads dependence, and then compounds. For most of the history of vertebrate life, the first strategy has been the better bet by a wide margin. It is why most fish do it. Independence at birth is cheap, and it scales. The second strategy is rare, expensive, fragile, and demands a specific set of conditions to work at all. Long lives, stable groups, reliable adults, and enough time for the investment to pay back. When it does work, it produces something that stops being limited by its own body, and that is what is now swimming into the white shark's hunting grounds. Look again at the sequence of documented events, and what they show is not one behavior. It is a behavior being optimized. Group attacks in South Africa involving between 2 and 6 killer whales taking up to 2 hours, a solo attack by a single whale that was finished in under 2 minutes, coordinated flipping in the Gulf of California, executed consistently across events years apart with juveniles present and the food shared. A confirmed predation on the other side of the planet in Australian waters, on a shark of 4.7 meters, with the liver and adjacent organs taken. 2 hours to 2 minutes. 6 animals to 1. Adults to juveniles. 1 coastline to 4. Every one of those numbers is moving in the direction you would expect from a technique that is being practiced rather than a behavior that is being repeated. And here is the detail that makes it land properly. In every one of those events, the shark is still exactly the same animal. Nothing about the white shark changed between the 2-hour version and the 2-minute version. Same body, same senses, same reflexes, same everything. All of the change happened on the other side. That is what it looks like when one participant in a relationship can update and the other cannot. There is an obvious objection at this point, and it deserves an answer, because it is the objection anyone who has spent time around sharks will raise. White sharks are not stupid. They are not simple. Treating them as reflex machines is its own kind of error. That objection is correct. White sharks show behavioral flexibility that has surprised people repeatedly. They adjust hunting tactics to conditions and to the specific layout of a site. They show individual differences in how they approach prey and how much risk they take. Individuals return to the same locations year after year across enormous distances, which requires navigation abilities we still do not fully understand. Some populations aggregate in ways that involve tolerance, spacing, and something resembling a social hierarchy based on size and residency, which is not the behavior of an animal with no social capacity whatsoever. There is even evidence that individual sharks learn. They get better at hunting with experience. Larger, older sharks at well-studied sites have shown higher success rates than smaller ones, which is consistent with practice rather than pure size. All of that is real, and none of it solves the problem, because individual learning has a hard ceiling that social learning does not. Whatever a white shark works out, it works out alone, and it dies with the animal. There is no accumulation. Every generation starts from the same baseline and climbs the same curve using the same trial and error, and no generation begins higher up than the last. That is the actual difference, stated as cleanly as it can be stated, not intelligence, not brain size, which is a measurement people love to quote and which explains far less than they think, not aggression, not size. The difference is whether what one animal figures out can survive that animal's death. And that difference has a strange consequence when you follow it backwards in time, because it explains why the white shark looks the way it does in the first place. Sharks as a group are extraordinarily old. Cartilaginous fishes have been in the ocean for hundreds of millions of years, through mass extinctions that erased most of what was swimming alongside them. That longevity gets used as a compliment. The shark as a perfect design that never needed to change. And the compliment is misleading, because sharks have changed constantly, and the lineage is full of forms that no longer exist. The white shark itself is not ancient. Teeth attributed to the species appear in the fossil record within the last few million years, which makes it, by the standards of its own group, a recent arrival. It is a young species riding a very old body plan. And it emerged into an ocean that already contained large marine mammals, already contained seals, already contained the ancestors of the animals that now hunt it. So this is not a relic being overtaken by something modern. These two predators grew up in the same ocean, and they took opposite routes through it. One route optimized the individual. Everything the white shark has is aimed at making a single animal, on its own, as complete as it can be. Sensory coverage, from kilometers out to skin contact, a heat system that expands its usable range, weapons that renew themselves, a body that carries its own fuel and its own flotation in the same organ. It is a self-contained solution, and it works so well that the design has barely needed to move for a long time. The other route optimized the group and accepted a mediocre individual as the price. Strip away the reputation, and a killer whale on its own is not a particularly impressive weapon. It has conical teeth that grip rather than cut. It has no venom, no armor, no claws, no ability to breathe underwater, no capacity to detect the electrical signature of a hidden animal. It has to surface. Its young are useless for years. Take a single killer whale and put it in an ocean by itself with no group and no learned technique, and you have a large, powerful, hungry mammal with no idea what to do. The entire capability lives in the connections between them. That is why this whole comparison is unfair in a way that turns out to be the entire point. Putting a white shark next to an orca and asking which one is better is like putting a very good tool next to an organization. They are not the same kind of thing. The shark is the finest expression of one strategy. The orca is a completely different strategy that happens to occupy the same water. And the reason the shark loses is not that its strategy is bad. It is that its strategy is closed. The white shark has been solved. Every part of it works. There is nothing obviously left to fix, and that is precisely the problem, because a solved design has nowhere to go. It has no mechanism for responding to a change in the world, except waiting for the world to kill enough of its members that the survivors are slightly different. That is the only tool it has, and it is a tool that takes centuries. The killer whale has not been solved and never will be, because the parts of it that matter most are not in the body at all. They are in a set of behaviors that are being edited constantly by every individual that survives something new and swims back to a group that watches it. One is finished, the other is unfinished. Permanently. On purpose. That is why the shark runs. Now, before this becomes too clean, there is a correction that has to be made, and it cuts against the direction this has been traveling. The killer whale's advantage is not free, and it is not stable. It is currently one of the most fragile arrangements in the ocean. Everything about the culture depends on continuity. It depends on old animals staying alive long enough to be followed. It depends on groups staying together across decades. It depends on prey being predictable enough that a specialized technique keeps working. Break any of those, and the advantage evaporates, and it evaporates faster than it built. Populations that were reduced by past captures and killings did not just lose numbers. They lost structure. Some groups were left without the older animals that hold the knowledge, and there is no way to regenerate that from the outside. You can protect the water. You cannot restore a memory that was in a specific animal. The salmon-dependent populations demonstrate the failure mode plainly. Their prey has declined. They have not switched. They are, as far as anyone can tell, unable or unwilling to abandon a specialization that no longer feeds them adequately. In an ocean full of alternatives, what you are looking at there is a culture still running a technique built for conditions that no longer exist. The same mechanism that makes them so effective at hunting sharks makes them incapable of noticing, at a population level, that the world has moved, and the white shark is under its own pressure, from a direction that has nothing to do with killer whales. The number of white sharks in the ocean has never been large. They are slow to mature, slow to reproduce, and they occupy a position in the food web that is inherently sparse, because there is only ever room at the top for a few. On top of that, they have been killed for decades in nets set along beaches, taken as bycatch in fisheries that were aiming at something else, and pressured indirectly through the removal of the smaller sharks and fish that juveniles depend on, before they are large enough to hunt seals. The false bay decline is the clearest example of what that combination does. Whatever share of the blame belongs to killer whales, the sharks that vanished from that bay were already a population that had been thinned for a very long time by other things. So there is a version of this story that is much less satisfying and much more accurate than a duel between two predators. Two slow-reproducing, long-lived, highly specialized apex predators, both operating on thin margins, both vulnerable in different ways, meeting each other in an ocean that is being altered underneath both of them, faster than either can adapt. One of them can update its behavior in years and cannot escape needing air. The other can go anywhere in the water column and cannot update anything at all. Neither is winning. One of them is simply losing more slowly at the specific game of adapting, which brings this back to the beach and the body and the single clean opening behind the pectoral fin. That carcass is not evidence that the great white shark was overrated. Everything that has been laid out here argues the opposite. The animal is an extraordinary piece of biology, and every part of it is doing exactly what it was built to do, at a standard almost nothing else in the ocean can match. What the carcass shows is the limit of building a perfect individual. The shark arrived at that encounter with everything it had, and everything it had was the wrong category of thing. Warm muscle does not help against an animal that is not chasing you. Electroreception does not help against a hunter that already knows exactly where you are. A jaw does not help when your own nervous system has been switched off by being turned upside down. Speed does not help when the exit is covered. Against a coordinated group running a refined technique, an outstanding body is not an answer. It is just a bigger target. And yet the most unsettling part of this is not what has been documented. It is the size of what has not. Take the events that have actually been filmed and look at who is in them. In the Gulf of California, the sharks were juveniles. The animal killed by a single whale off Mossel Bay was a juvenile of roughly 2.5 meters. The Australian carcass was far larger, at 4.7 meters, which is nobody's idea of a small shark. And the South African carcasses have included large animals. Even so, a great deal of the clearest footage involves young sharks. That raises a question nobody has settled. Is a full-grown white shark a genuinely different proposition, or is it simply harder to catch on camera? The flipping technique depends on getting the shark inverted and holding it there. A juvenile is a manageable object for a group of animals that size. A large adult female at 5 meters or more and well over a ton is a considerably heavier problem. And the events involving large sharks have generally involved groups rather than individuals and appear to have taken longer. So there may be a size threshold, there may not be. What exists is a set of documented events skewed toward the encounters that are easiest to observe and easiest to complete. Easiest to do best, and the honest reading is that we do not yet know how the odds change as the shark gets bigger. There is also an objection that has to be dealt with before any of this can be trusted, and it is the first thing a careful person should ask when they hear about a carcass with an organ missing. How do we know the killer whales killed it, rather than found it? Scavenging is common in the ocean, and it destroys a lot of confident conclusions. A shark that died of something else entirely, then drifted, then got opened by whatever arrived first, would leave a body that superficially resembles a predation. Wound interpretation on a decomposing carcass is notoriously unreliable, and bite marks accumulate after death. This is exactly why the Australian case matters more than a dramatic photograph would. The wounds on that carcass were not all the same, and the genetic work separated them. The major bite, the one matching the pattern used to open a shark's body cavity, carried killer whale DNA. Other bites carried the DNA of 7 gill sharks. That is a sequence, not a snapshot. One animal made the opening, others came afterwards. Scavenging did occur. It just was not the killer whales doing it. And in the Gulf of California, the objection does not arise at all because the animals were filmed pursuing living sharks, forcing them to the surface, and turning them over. There is no ambiguity about whether the shark was alive at the start of the encounter. Both lines of evidence are needed. The footage shows the behavior. The genetics shows the same behavior in places where nobody was watching. Together they close a gap that neither could close alone. That is not the only gap. The gaps are the most interesting part of this whole story because each one is a place where the picture could still turn over again. We do not know how a white shark detects killer whales. That is a remarkable thing to have to admit given how dramatic the response is. Whether it is acoustic, chemical, a reaction to the scent of a dead shark, or something else entirely remains unresolved, and the answer changes what kind of animal we are describing. A shark responding to the smell of its own species' remains is doing something very different from a shark recognizing a predator. We do not know whether the response is innate or learned. If it is innate, it implies a long shared history and a threat old enough to be wired in. If it is learned, it implies that white sharks retain and act on individual experience of a specific danger, which would be a meaningful upgrade to what anyone credits them with. Both would be significant findings, and neither has been demonstrated. We do not know whether the liver-targeting behavior arose once and spread, or arose independently in separate oceans. Killer whale populations in South Africa, Australia, Mexico, and California do not form a single connected community, and the technique showing up in all four either means a great deal about how far cultural transmission reaches, or means that the same solution is obvious enough that any sufficiently coordinated predator will eventually find it. We do not know why killer whales take the liver and leave the rest. The energy argument is strong. It is still an argument, built on what was left behind, rather than on anything observed inside the decision. We do not know whether the tonic immobility is being induced deliberately. The consistency of the footage points that way. Consistency is not intent, and we do not know what the long-term outcome is for white sharks in the regions where this is happening. Local displacement is documented. Population consequences are not. The Neptune Islands work is a direct reminder that the tidy version, in which every shark absence is a killer whale's fault, does not survive contact with a long data set. That list is not a weakness in the story. That list is the story, because every single one of those questions is currently answerable with the tools that already exist. 20 years ago, none of them were. Nobody could have asked what a shark does in the hours after a killer whale passes, because nobody could see where the shark went. Nobody could ask whether a specific pod was teaching a specific technique, because nobody had a camera in the air. Nobody could ask which animal made a wound, because a wound was a matter of opinion. Now all of that is routine, and the pace of the answers is going to accelerate, which means the version of this you are hearing right now is temporary. It is a snapshot of a picture that is still being assembled, in a field where the last decade has overturned more than the previous 50 years managed. The reasonable expectation is that some of what seems solid here will be complicated within a few years, and the complications will be more interesting than the current version. That is what a live scientific question looks like from the inside. There is one more thread to close, and it is the one the whole story has been quietly pulling on since the first empty seal colony. The behavior appears to be spreading, and there is reason to think the ocean itself is helping. The Gulf of California work raised the possibility that shifting conditions are changing where juvenile white sharks spend their time. Young white sharks use particular coastal areas as nurseries, and those areas are defined largely by water temperature. Warm the water, and those nurseries move. Move the nurseries, and you change which predators the juveniles are living alongside. If that is what is happening, then this is not simply a story about clever whales. It is a story about a changing ocean putting two animals into contact more often than it used to, and one of them being far better equipped to take advantage of a new opportunity than the other is to avoid it. That framing is a hypothesis, and it should be treated as one. It also happens to be exactly the kind of situation where the difference between a body and a technique matters most, because the animal that can only respond by evolving is the animal that gets caught out when conditions change fast. So here is where all of it lands. The great white shark is not overrated. It is not weak, not stupid, not a paper monster, and not a failure. It is one of the most complete predators the ocean has ever produced. And if the contest were about the quality of a single animal, it would win, comfortably, against almost anything alive. The contest is not about that, and it never was. Everything that makes the white shark terrifying to us is narrow. The ambush works on prey that cannot see it coming. The senses are built to find animals that are not looking for the shark. The warm body buys performance in cold water and charges a permanent fee in calories. The weapon is mounted on the same structure that holds the eyes, which means the animal has to protect itself from its own hunting. Every advantage is specific, and every advantage has a bill attached, and against a coordinated, communicating, technique-carrying group, not one of them applies. The shark did not lose on force. It lost on information. It lost because the other animal could be told things. It lost because the other animal's mother knew something and passed it on. And that thing got sharper over generations while the shark stayed exactly the same. It lost because 2 hours became 2 minutes on one side of the encounter and nothing whatsoever changed on the other, which forces a rewrite of a word that has been sitting at the center of this from the beginning. Apex predator was never a ranking of strength. We read it that way because it is the reading that feels right, and because the phrase arrived attached to animals with impressive teeth. What the ocean actually rewards at the top is not the ability to kill. Killing is easy. Killing is available to a great many animals that are nowhere near the top of anything. What the top of a food web requires is the ability to keep solving a problem that keeps changing. Prey moves, prey learns. Water warms, runs collapse, colonies shift. Coastlines get fished out. A predator at the top is not fighting other predators for a crown. It is fighting the fact that the conditions that made it successful are always in the process of ending, and its position depends entirely on whether it can keep up with that. Measured that way, the ranking looks completely different. An animal with a magnificent body and no capacity to update is holding a position it cannot defend against change. It is not at the top because it is strong. It is at the top because nothing has yet demanded something the body cannot deliver. An animal with an ordinary body and a mechanism for accumulating solutions is holding a position that can be defended, at least for as long as the mechanism survives. The white shark has spent a very long time in the first category, and it worked, and it is still working almost everywhere. Then something arrived that demanded a response the body could not produce, and the shark discovered that it had exactly one option available, which was to leave. Go back to what that looks like on the water, because the abstraction deserves to be turned back into a picture. Dawn at a seal island. The light is still low, the water is gray and moving, and the fur seals are heading out from the rocks in their groups, pushing through the deep channel where they are most exposed. This is the exact window and the exact place where, for as long as anyone had been watching, something heavier than everything else in that water came up from 30 meters below and left the ocean entirely with a seal in its jaws. Now the seals cross that channel and nothing comes up. The water is the same. The light is the same. The seals are the same seals, and for a while their behavior is the same too, because a colony does not immediately unlearn a danger that has shaped it for generations. They still travel in groups. They still hurry through the deep part. They are still running a program written by a predator that has stopped arriving. Then, slowly, the program relaxes. More seals survive their first year. More seals in the water means more pressure on the fish underneath them. In the kelp forests along the edge of the bay, a different shark that used to keep to its own areas is moving through the shallows in numbers, because the animal that used to make that a bad idea is not there to enforce it. The species that seven gills eat begin to thin out. The whole bay is running a different set of rules, and none of it was decided by anything with an opinion. It is just what happens when a constraint is removed. None of this is restoration, and none of it is collapse. It is reorganization. And reorganization is what ecosystems do when the animal at the top stops showing up. That is the real measure of what a white shark was doing there, not the kills. The kills were relatively few. What it was doing was making a large volume of water dangerous every dawn for decades. And everything in that water was built around the danger, and the danger was removed by an animal that may have only passed through. There is something genuinely uncomfortable in the arithmetic of that. A handful of killer whales, present occasionally, killing a small number of sharks, capable of resetting the predator structure of an entire coastline for years, not by eating their way through it. By being frightening enough that the previous holder of the position decided the risk was not worth the food and left and took the whole structure with it. The shark's decision was correct. It was also enormous, and it was made in an afternoon. It is worth saying clearly that the white shark is not finished as a species. It has not been driven out of the ocean. It has not been replaced. In most of its range, on most days, in most water, it is doing exactly what it has always done, and doing it superbly. What has changed is that the story we told about it, the one where it sat alone at the top with nothing above it and nothing to fear, has been dismantled by better observation, and it will not be going back together. That story was never the shark's fault. It was ours. We looked at an animal that could not be beaten by anything we could see, in an ocean we could barely observe, and we mistook the limits of our own watching for the limits of what was out there. Then the tags went on, and the drones went up, and the swabs went into the wounds, and the thing that had presumably been happening out of sight the whole time became visible. So what should you actually take from a great white shark now? Not that it is weak. Everything in this story argues the opposite. And if the comparison had been with anything else in the ocean, the shark would be the answer. Not that killer whales are simply superior because their entire advantage rests on old animals staying alive, groups staying intact, and prey staying where the culture expects it, and every one of those is currently under strain. What the comparison actually exposes is a limit that has nothing to do with either animal individually. There is a ceiling on what a body can achieve alone, and the white shark is pressed hard against it. It is close to the best possible version of a solitary predator, and being the best possible version of a solitary predator is not enough against something that does not have to be solitary. The shark brought everything it had. The problem is that everything it had was finished being invented a long time ago. There is a last image, and it is not a fight. It is the water above a seal colony at first light. The specific patch of open ocean where the sharks used to hold position 30 meters down and wait for a silhouette to cross the surface. Look into it now, and there is nothing to look at. No dark shape resolving out of the blue. No shadow tracking under a group of seals. No pressure line moving up from below. Just an ordinary column of gray-green water doing nothing at all, in a place that used to be the most dangerous few hundred meters on that coast. The absence is not dramatic. That is what makes it stay with you. An ecosystem missing its apex predator does not look wrong. It looks calm. And somewhere out past the edge of what a camera can see, moving in a line, breathing on a shared rhythm, there is a group of animals carrying a piece of information, not in their genes, in their behavior. A sequence. Find the shark, force it up, turn it over, hold it, open it between the fins, take the liver, share it, leave. A procedure that has been getting shorter and cleaner every time anyone has managed to watch it, that has now turned up on 4 coastlines. And that will outlive every individual animal currently performing it because there are young ones in the group watching it happen. That is the thing worth being unsettled by. Not the teeth, not the size, not the kill. The fact that one of these animals will die and take everything it ever learned with it, and the other will die and leave the technique behind, still improving in the water, being practiced by animals that are not born yet. The great white shark was never the problem. It is a perfect answer to a question the ocean stopped asking exclusively. And the next time you see one on a screen, gliding out of the blue, with that unchanged face, and those replaceable teeth, and that buried furnace of warm muscle, hold on to the thing that has actually been established here because it is stranger than the monster version ever was. You are not looking at the top of the ocean. You are looking at the finest solitary predator the sea has ever built, running the exact same program it has run for millions of years, in water where something else has started keeping notes.